Assalamu alaikum, welcome again. Here in this problem we have two cases. At the beginning, the information that we have, before we apply the insulation, we have a spherical tank and the temperatures are given. So we can know the heat loss from here, okay? So what percentage reduction in heat loss we will get between these two cases, okay? So at the beginning, we have the heat loss just caused by the convection. So we can say that Q is equal to HA delta T, which is calculated by just putting the temperatures, and H is given also. So area will be pi d squared or 4 pi r squared. Cross section, just surface area for a sphere is just 4 pi r squared. That's also can be calculated by pi d squared. So we have pi times 1 squared. You have meter square, this unit as of area. Then you have unit of the temperature difference there. So they will cancel each other and you will have watt. How many watts we have for this, the first case? Let's calculate that. We have 25 times pi times 1 square, which is on 1. So then you will get 105. So the heat loss or heat flow for this case, 8,246 watts. Watts. So after that we need to find the other case, okay? Let's move to second case when we apply the insulation. So the heat flow that comes from the conduction will also be lost as convection. So we can only find the conduction. That will be enough. So for the conduction, okay, why we don't use overall heat transfer here? Because we already know the temperatures at the middle, okay? So if we don't know this one, so we will use this one and the other one to find Q. But here we know the temperature of the insulation layer, okay? So it will be 40 degrees of Celsius, okay? Then we can calculate the conduction. So the heat rate for the conduction is given as 4 pi. From the table you can bring it, K delta T over 1 over R inner minus 1 over R outer, okay? So it's 4 pi. The thermal conductivity of the urethane, this is the insulation layer, is given as 0.018 watt per meter degrees of Celsius. Then you have delta T, which is 120 minus 40 degrees of Celsius. Then you have 1 over R inner. R inner just 1, okay? 1 over 0.5, I'm sorry, 0.5. You have the unit of 1 over meter. Then minus R outer, we don't know that value. Let's keep it, 1 over R outer. So this heat flux that's coming with conduction will be equal to Q convection, okay? So for this case, this is Q conduction, and that will be equal to also Q convection. They have the same flow, okay? So in equals to out, okay? Basically for the surface. So convection term will be equal to H times A times delta T. But now the delta T is 40 minus 25, okay? This is the difference. And you have area 4 pi R naught square, okay? 4 pi R naught square. I don't know that value. I will just use these two equations to find R naught. Okay? So actually if we show in schematic, it will be something like this. Here you have T infinity, here you have T2, here you have T1, and you have one flow. The Q that comes from here is same as what like passes through T2 and T infinity. So they are equal to each other. So when you equate these two, Q conduction is equal to Q convection, you can get R naught. So let's do that from the calculator. Okay, let's try to solve for R naught. Actually, we have 4 pi at both sides, so we can neglect those 4 pi's, okay, when we put in the calculator. So we have just k multiplied by 80 and 1 over 0.5 minus 1 over R naught, okay, which is x. Then you have equal to 25 times 4 pi. Also is here. You can skip that. We cancel that term, times 25 for this term. So now when you say shift and solve, you should guess R naught value because it is second order. So you will have 2 roots. So to reach the root that we need, let's say it is 0.9. Okay. So if the other root is just equal to 0 or like near to 0, so we should guess something like near to our value. So let's see if we could find that R naught. You can also do some algebra to find that. You see here in the second order equations sometimes that will be tricky to find the root. Okay. I think okay, it's better to find it from the other calculating tool or do some algebra. Okay, let's do some algebra, okay? Because sometimes it is tricky to find that. So 0.018 times 80 over, let's say 1 over 0.2 is just 2 minus 1 over R naught is equal to 25 times R naught square times 25, okay? So if we send other guys to there, so it will be 0.018 times 80 over 25 square. You have 25 square there, so you have R naught square 2 minus 1 over R naught, okay? So this term, let's find that term. So we get 2.304 to the power minus 3. You have R, okay, 2 R naught square minus R naught, okay? And if you see 2 R naught square minus R naught, and you have other term here, let's write it, let's divide both sides by 2. So you have R naught square minus R naught over 2. And you have this term divided by 2, and you also bring it to other side. Okay, so it will be, let's divide this by 2. You will get 1.152 times 10 to the minus 3 is equal to 0. Okay, so if you remember the root formula, it's minus b plus minus square root of b squared minus 4ac over 2a, right? So let's find what is b here. It's minus 0.5. Okay, so it will be 0.5 plus or minus b squared, which is 0.5 squared, minus 4ac. Okay, so 4 times minus, we cancel the other minus. So you will get something like this over 2 times a, and a is 1. Okay, so let's find the value. Actually, I'm interested in the not negative one, positive one. I get the positive one, that will be my result. Okay, plus. Okay, 0.502, okay, meter as a radius out, okay, outer radius. So the outer radius minus inner radius will give you the thickness, which is 0.502 minus 0.5. So it is 0.002, okay, meter, which is just 2 millimeters. Okay, the thickness that we need is 2 millimeter, and from that information also you can find the heat flux. Okay, so heat flux is HA delta T, which is 25 multiplied by 4 pi R square. R is now given 0.502 square times the delta T, which is 25 degrees of Celsius, right? 25 for the convection part. So let's find 25 times 4 pi times 0.502 square, or we can say answer square since we stored that value, times 25. Okay, so that will be 1981 watts. And the ratio, this is 2, so Q before, Q after insulation. After, okay? So you have 8,246 over 1981. Let's say answer, so we will get 4 times, 4.2 times. Okay? The percentage of them, or also you can say, okay, it will be 420%, the percentage between them. Or if we want to just make the reverse to see how many percent we saved. Okay, so just take minus 1. You have 0.0 0.24, that means it is just 24% of the previous one. Okay, we saved approximately 75% of heat energy. I hope you enjoyed this question. See you at the next video. Thank you for watching.